Hey there. So let's talk about something we all live through every single day, but maybe don't stop to think about all that often. The seasons. Why do we get these long, beautiful, warm summer days and then these short, cold winter nights? It's this basic rhythm of our planet. And believe me, the reason why is just, it's absolutely fantastic.
All right, let's just jump right in with the big one, shall we? Why are summers hot and winters cold? I mean, what's really going on up there that gives us blooming flowers in the spring, beach days in the summer, crunchy leaves in the fall, and, well, all that snow in the winter?
A lot of people think, and honestly, it makes perfect sense, that we have seasons because our planet just gets a little cozier with the sun in the summer, and then it's farther away in the winter. Simple enough, right? And look, it's not a crazy idea, because it's true that our orbit isn't a perfect circle. It's an ellipse, it's a little squashed, which means our distance to the sun does change. There's a closest point, which we call the perihelion, and a farthest point, the aphelion. And this is the part that just blows that whole theory out of the water. For those of us up here in the northern hemisphere, our planet is actually closest to the sun in the beginning of January, right in the middle of winter. So, yeah, distance can't be the main reason. Something else has to be going on. So if it's not distance, what is it? Well, the real hero of this story, the thing that explains everything, is the Earth's tilt. It really all just comes down to having a tilted point of view. So to get this, we've got to talk about Earth's axis. Just picture this imaginary pole, kind of like a skewer, going right through the center of the planet from the North Pole to the South Pole. That's what our planet spins around, once every 24 hours. A great way to picture it is like a basketball player spinning a ball on their finger. That invisible line it's spinning on, that's the axis. Okay, now here is the magic number. Earth's axis isn't perfectly straight up and down compared to its path around the sun. Nope, it's tilted, and it's tilted by 23.5 degrees. This number, this one little lean, is the key to absolutely everything. So why does a little tilt matter so much? Okay, think of the sun's energy like it's a flashlight. If you shine that flashlight straight down on the floor, you get a really small, bright, intense circle of light and heat, right? That's direct sunlight. But if you take that same flashlight and shine it at an angle, the beam spreads out. It covers way more area, but the light is a lot dimmer and the energy is all spread out. That's indirect sunlight. So as our tilted planet makes its year-long journey around the sun, different parts of the globe get those direct flashlight-like rays at different times. And this whole journey is marked by 4 really important moments: the solstices and the equinoxes. Okay, so you can see the whole dance right here. And the most important thing to notice is that as the Earth moves, its axis always points in the same direction out in space. That's the secret sauce. So when the northern hemisphere is tilted toward the sun around June, we get that direct, concentrated energy. Hello, summer. Then, 6 months later, in December, we're tilted away from the sun. We're getting those weak, spread-out rays, and that's our winter. And right in between, in March and September, the tilt is kind of sideways to the sun, so nobody gets the direct hit. So these 4 key dates break down into 2 main types. On the solstices, our tilt is at its absolute maximum, either toward or away from the sun. That gives us our longest or our shortest day of the year. But on the equinoxes, the tilt is perfectly sideways. And on those days, day and night are almost exactly equal in length, pretty much everywhere on Earth. And here's a really cool little piece of trivia for you. The word solstice actually comes from Latin, and it means sun stands still. And that's because if you were to track the sun's highest point in the sky every day, you'd see it climb higher and higher as summer approaches, and then it looks like it just pauses. It stands still for a few days at its peak before it starts heading back down for winter. Just a beautiful observation from our ancestors. All right, so that's the big picture, the astronomy of it all. But what does this cosmic tilt actually mean for us, down here on the ground? How does it shape the world we actually live in? I mean, just look at these satellite images from NASA. They're incredible. On the left, that's Earth in June. You can see how green and full of life the northern hemisphere is. That's that direct sunlight at work. But then look at the right. In December, the whole pattern flips. The north is kind of brown and sleeping, and the southern hemisphere is greening up because it's their turn for summer. It's like the whole planet is taking a deep breath in and then out, all because of that tilt. But if you want to see where this gets really extreme, you have to go to the poles. I mean, because of the tilt, the North Pole is angled so far toward the sun during its summer that the sun literally never sets. For months, it just circles the horizon. That's the famous midnight sun. And of course, the flip side is a winter of 24-hour darkness for months on end. Wild. Okay, so that same spin that gives us day and night, well, it creates a bit of a problem, right? How do you schedule a meeting when it's noon where you are, but the middle of the night for someone else? We needed a system.
And the solution we came up with? Time zones. We basically sliced the globe into 24 vertical sections. The idea is that everyone inside one of those slices agrees on what time it is, and it's all based on where the sun is. The starting line for all of this, the reference point, is the prime meridian in Greenwich, London. And that sets the standard time we call Coordinated Universal Time, or UTC.
And honestly, the system is way simpler than you might think. Every time zone is just a certain number of hours ahead or behind UTC. We call it an offset. So, for example, New York City is UTC minus 5 hours. So if you know it's 2 p.m. UTC, you just subtract 5, and boom, it's 9 a.m. in New York. It's a really clever system to keep a spinning world in sync. Okay, so we've got Earth figured out, but what about our neighbors? Does this whole tilt thing cause seasons on other planets too? Let's take a quick trip around the solar system and find out. All right, prepare to have your mind blown a little bit. On the left, there's our planet Earth, with its gentle little 23.5-degree tilt. On the right, that's Uranus. And as you can see, Uranus isn't just tilted, it's been knocked completely over on its side, and its seasons are just beyond extreme. One pole will face the sun for 42 Earth years straight in one long summer day, while the other pole is in total freezing darkness for those same 42 years. And it's not just Uranus. Every planet has its own wild seasonal story. Mars actually has a tilt that's really similar to ours, but its year is way longer, so its seasons are almost twice as long. Saturn takes about 29 years to go around the sun, so each of its seasons last for more than 7 Earth years. It just goes to show you how that simple combination of tilt and orbit creates totally unique worlds out there. So when you really get down to it, from why our trees lose their leaves to those 42-year-long nights on Uranus, it's not about how close we are to the sun. It really is all about that tilt. And that's really what this is all about. The next time you go outside, just for a second, look up. Pay attention to the path the sun is taking across the sky. Notice how high it is at lunchtime. That arc you're seeing, it's telling you a story. It's the story of our planet's tilt, its constant journey, and your precise spot in this huge cosmic dance. Thanks for hanging out and exploring this with me.